There is a crime happening right now. It is happening above your head, in the dark, everywhere at once. Someone, or something, is stealing energy from the universe. You know the rule. You learned it in 8th grade. Energy cannot be created or destroyed. It can only change form. A falling rock turns height into speed. A burning log turns chemical bonds into heat. The total amount of energy in the box always stays the same. That is the first law of thermodynamics. It is the sacred commandment of physics. We trust it. We build our engines, our cities, and our entire understanding of reality on it. But here is the part nobody tells you. When we look up at the night sky, at the oldest light in the universe, that law is broken. That light has lost energy, massive amounts of it, billions of atomic bombs worth of energy, gone, vanished, deleted from existence. It didn't turn into heat. It didn't turn into potential energy. It isn't hiding behind a star. The universe is leaking. So where did it go? Did the laws of physics break? Or did we just find a trapdoor in reality that leads to somewhere else? Stop what you're doing. Put your phone down. We need to follow the evidence. Let me show you. You need to understand why this is a crisis. Conservation of energy isn't just a suggestion. It is the bedrock. It is the concrete foundation under your feet. In physics, we have a lot of rules that are kind of flexible, but not this one. This one is sacred. Do this right now. Close your eyes. Imagine you are standing in a massive lecture hall. Hanging from the ceiling is a bowling ball on a long steel cable. You grab that heavy ball. You pull it back until it is touching the tip of your nose. You are staring at 50 pounds of dense steel. Now you let go. You don't push it, you just release. The ball swings away, whoosh. It flies across the room, stops for a split second, and swings back, rushing straight toward your face. Here is the question. Do you flinch? If you trust the laws of physics, you don't move a muscle. You stare that ball down. Because you know in your bones that the ball cannot come back higher than where it started. It cannot smash your face. Why? Because energy is currency. When you pulled the ball up, you gave it potential energy, height. When you let go, it cashed that height in for speed, kinetic energy. At the bottom, 0 height, max speed. On the way back up, it trades the speed back for height. It's a perfect exchange, an accountant's dream. The books always balance. Every single joule is accounted for. People call this time translation symmetry. We'll get to that later. But your intuition just calls it fairness. We believe the universe is a closed box. If you lose energy here, it must pop up over there. It's comforting. It makes sense. But here is the catch. That bowling ball experiment works because the room you are standing in isn't changing. The floor is solid. The walls are still. But what happens if the room itself starts to stretch? What happens if the bank, where you store your energy, starts changing the value of the currency while it's in your pocket? That is exactly what light is facing. Let's look at the victim of this crime, the photon. To understand how the theft happens, you have to stop thinking of light as a bullet. People say particle of light, and you imagine a little BB pellet zip-lining through space. Wrong. That model fails here. You need to think of light as a rope. Imagine you're at the gym. You have one of those heavy battle ropes. You grab the end. You start shaking it up and down. Snap, snap, snap. You are sending waves down the line. Now do a sprint. Shake it furiously. Fast ripples. Up and down, up and down. You are sweating. Your heart is pounding. Why? Because you are pumping massive amounts of energy into that rope to make those short, tight waves. High frequency equals high energy. Now slow down. Just a lazy wobble. One big wave every second. You aren't tired anymore. It's easy. Low frequency equals low energy. Here is the part nobody tells you. For a photon, frequency isn't just a number, it is color. Color is literally just a measure of how much energy a photon is carrying. Think about blue light. Blue is that gym rope being snapped furiously. It is tight, short, and aggressive. It packs a punch. That is why UV light, which is super blue, burns your skin. It has enough raw energy to smash into your DNA and break it. Now think about red light. Red is the lazy wobble. It is a long, stretched out wave. It's weak. It hits your skin and just bounces off. It's poor. So here is the rule of the cosmos. Short waves, blue, equals rich. Long waves, red, equals poor. This is the only thing you need to remember. Energy is the shape of the wave. If you stretch the wave, you aren't just changing its shape, you are draining its bank account. And the universe, it loves to stretch things. Let me warn you right now. If you Google, "Why does light stretch?" you will find a lie. It's a very common, very convincing lie. It's called the Doppler effect. Here is the part nobody tells you. You have heard this before. You are standing on a sidewalk. An ambulance comes screaming down the street. Wee woo, wee woo. As it races toward you, the siren is high-pitched, screeching. Then, vroom, it passes you. Suddenly the pitch drops. It goes low. Wah, woo, wah, woo. Why? Because the ambulance is physically squishing the sound waves in front of it and dragging them out behind it. Most people think, aha, that's it. The universe is expanding, galaxies are moving away from us like ambulances, so the light gets stretched out. Wrong. Stop thinking that. Delete that image from your brain. That is Doppler redshift. It happens when things move through space. But what we are talking about is infinitely stranger. The galaxies aren't moving through space away from us. They are sitting still. Imagine drawing two dots on a deflated balloon. Those are galaxies. Now blow up the balloon. The dots get farther apart. Did they move? No. They are still in the same spot on the rubber. The rubber itself grew. This is critical. If a galaxy was just moving away, like a car, the energy wouldn't be lost. It would just be shifted. The driver sees one thing, you see another, but the total energy is conserved in the system. But cosmological redshift is different. The light isn't just looking different because of motion. The wave itself is being physically pulled apart by the fabric of reality. The ambulance driver is fine. The car is fine. But the road beneath the wheels is stretching like taffy. And that stretching road is doing something violent to the light traveling on it. It is rewriting the laws of physics as we speak. Let me show you exactly how the universe commits the crime. We need an analogy that isn't from a textbook. We need one that you can feel. Do this right now. Imagine you are an ant, a tiny, curious ant. You are walking on a giant rubber band. You start at one end. You want to walk to the other end. Now, imagine I draw a wave on that rubber band with a marker. Just a simple squiggly line, up, down, up, down. Let's say the squiggle is tight, like a compressed spring. It has a lot of energy stored in it. That wave is a photon. It's blue. It's powerful. You start walking, but while you are walking, I start pulling on the rubber band, slowly, just stretching it out. What happens to the squiggle? It doesn't disappear. It doesn't break. It gets longer. The peaks get farther apart. The valleys get wider. The wave is physically stretching. If the wave was 1 inch long when you started, now it's 2 inches, then 4, then 10. Now, remember the rule from Chapter 2? Short equals rich, long equals poor. As I pull that rubber band, I am robbing the wave. I am taking its tight, energetic coils and turning them into lazy, weak wobbles. I am literally sucking the energy out of the wave. Where does that energy go? Does it go into the rubber band? Does it heat up the ant? No. The wave just lost it. It had 10 units of energy, now it has 5, then 2, then 0.1. That is what happens to light in our universe. Space itself is expanding. Every second, the distance between galaxies grows. And as that space grows, it grabs the photons traveling through it and stretches them. A photon leaves a distant galaxy as a powerful blue-hot gamma ray, but it has to travel for 13 billion years through expanding space to reach us. By the time it hits your telescope, it's been stretched so much, it's not even visible light anymore. It's a weak, pitiful radio wave. It lost 99.9% of its punch. It started as a bullet. It arrived as a gentle breeze. So the question is, where is the missing bullet? We need to check the ledger. It's easy to wave your hands and say, oh, it's just a little energy here and there. Wrong. This isn't a rounding error. This is a catastrophe for conservation. Let's do the math. The cosmic microwave background, CMB, you've heard of it. It's the afterglow of the Big Bang. When the universe was a baby, just 380,000 years old, it was hot. Imagine the inside of a blast furnace. The entire universe was glowing orange hot, about 3,000 degrees Kelvin. That glow was visible light. Every single photon back then was packed with energy. They were buzzing around like angry bees. If you were there, you would have been incinerated instantly. But then the universe started expanding and expanding and expanding. Remember the rubber band? Those angry, hot photons have been traveling through stretching space for 13.8 billion years. Today, when we catch those photons with our radio telescopes, they're not 3,000 degrees, they're not visible light, they're cold, they're microwaves. Their temperature, 2.7 Kelvin. That's minus 270 degrees Celsius. That's barely above absolute zero. Let me say that again. We started with a universe full of 3,000-degree fire. We ended up with a universe full of minus 270-degree ice. Where did the heat go? We are talking about enough energy to boil every ocean, on every planet, in every galaxy, 1 trillion times over. It didn't go into heating up the gas between stars. It didn't go into making black holes. It didn't go into dark matter. It just vanished. If you add up all the energy in the CMB photons today, it is a tiny fraction of what it was at the beginning. It is like starting a bank account with $1 billion, coming back 50 years later and finding out you have $4.50 left. And the bank says, oh yeah, inflation took it. But inflation usually means money moves around. Here, it just disappeared. This is the scandal. The universe is cooling down because the light is losing its punch, and the energy is simply gone. Wait, you are suspicious. You should be. Your brain is yelling at you. Energy can't just be gone. It's tempting to think we are just looking at it wrong. Surely there is an explanation. Surely the energy is hiding somewhere. Let's check the alibis. Alibi number 1, heat. Did the light hit something and warm it up? Maybe the photons bumped into gas clouds and made them hot. Wrong. Most of space is empty. The photons travel for billions of years without hitting anything. They don't interact. They don't transfer their energy. They just get stretched. So, no heat. Alibi number 2, gravity. Did gravity steal it? Maybe the photons had to climb out of a gravity well, like throwing a ball up a hill. Also wrong. The universe is expanding everywhere at once. There is no up or down for the entire universe. The photons aren't climbing out of a hole. They are just coasting. Gravity isn't taking a cut. Alibi number 3, potential energy. Maybe it's stored in the fabric of space itself, like stretching a spring. Maybe the energy went into the tension of the universe. This is the most common guess. It sounds smart. Oh, the energy is just potential now. Wrong again. If that were true, we could get it back. If the universe stopped expanding and started shrinking, would the light suddenly turn blue again and get its energy back? Technically, yes. But here is the problem. The universe isn't going to shrink. It's accelerating. It's getting bigger faster. So even if you call it potential energy, it is potential energy that can never, ever be cashed in. It is locked away in a vault that is flying away from us at the speed of light. For all practical purposes, it is deleted. Every physicist has tried to save the first law of thermodynamics here. They have tried to invent a way to make the books balance, but the truth is uncomfortable. The energy really is missing. And to understand why, we have to meet the woman who figured it out before anyone else. Her name was Emmy Noether. She is the most important physicist you have never heard of. Seriously, Einstein called her a genius. She basically invented the rules that make physics work. And here is what she discovered. She figured out that every single conservation law comes from a symmetry. Let me translate that. Remember the bowling ball? The reason energy was conserved in that room was because the laws of physics didn't change over time. If you drop the ball today, it falls at 9.8 meters per second squared. If you drop it tomorrow, same thing. If you drop it in 1,000,000 years, same thing. This is called time translation symmetry. Basically, the laws of physics don't care what time it is. Noether proved something beautiful. She said, if the laws of physics are the same at all times, then energy must be conserved. It's a mathematical proof. It's ironclad. If time symmetry holds, energy conservation holds. Period. But what if the laws do change? What if the universe itself is changing? This is the bombshell. In an expanding universe, time translation symmetry is broken. Think about it. The universe today is bigger than it was yesterday. It is less dense. The distance between galaxies is larger. If you do an experiment today involving light traveling through space, the result will be different than if you did it 1 billion years ago. The path is longer. The expansion rate is different. The background of the universe is not static. It is evolving. And because the background is changing, the symmetry is broken. And because the symmetry is broken, conservation of energy is broken. Let me say that again. It is not a mistake. It is not a paradox. It is a feature. Emmy Noether predicted this. She told us exactly when conservation would fail. It fails when the system itself changes over time. And the universe is the biggest changing system there is. So, when light travels through an expanding cosmos, it loses energy. And that energy doesn't go anywhere. It doesn't transform. It just ceases to exist. The first law of thermodynamics only works locally, in your lab, in your engine, in your kitchen. But on the scale of the entire universe, it is a lie. Let's really drill this in. This is the part that breaks your brain. We are so used to thinking of time as something that just happens. Tick-tock, tick-tock. It flows at a constant rate. 1 second is always 1 second. But in an expanding universe, time is weird. Because the universe is getting bigger, the clock is effectively changing. The density of matter is dropping. The temperature is dropping. The curvature of space is changing. Everything is evolving. If you lived in a static, unchanging universe, one that stayed exactly the same size forever, energy would be conserved perfectly. Light would travel from one galaxy to another, and it would arrive with exactly the same energy it left with. Redshift wouldn't happen. The photon wouldn't stretch. It would just be blue forever. But we don't live in that universe. We live in a dynamic one. And because the universe is dynamic, the time translation symmetry that Emmy Noether talked about is broken. Think about a river. If the river is calm and steady, you can float a boat from point A to point B and predict exactly how much energy it takes. The water is the same everywhere. Conservation works. But what if the river starts to speed up? What if the riverbed starts to expand? What if the water itself starts to boil? Suddenly, your calculations are wrong. The boat arrives with less energy. Or maybe it arrives with more. The background has changed. And here is the punchline. We used to think the universe was the steady river. We thought it was just a stage where actors played out their parts. But the stage itself is moving. The floorboards are stretching. The ceiling is rising. And because the stage is changing, the actors, the photons, are losing their lines. They are losing their energy. And there is no conservation police to stop it. The universe doesn't care about your textbooks. It doesn't care about your steam engines. It only cares about expansion. Wait, stop. If you are paying attention, you should be terrified. I said the universe doesn't care about textbooks. But that's not quite true. The universe does have a bank, a very, very strange bank. Let's talk about dark energy. It turns out, while photons are losing energy, the vacuum itself is gaining it? This is the twist. When the universe expands, it creates more empty space, more vacuum. Most people think vacuum means nothing. But in quantum mechanics, the vacuum is something. It has energy. Not much, but a tiny, tiny amount. Let's call it vacuum energy density. Here is the weird part. If you take a box of gas and expand it, the gas gets thinner, the density drops, the energy spreads out. But if you take a box of vacuum and expand it, the density stays the same. Wait, what? If you double the size of the box, you have twice as much vacuum. And since the density is constant, you suddenly have twice as much energy. Where did that energy come from? It came from nowhere? It just popped into existence because there is more space now? Yes. So while photons are losing energy by being stretched, the vacuum is gaining energy by being created. Do these two things balance out? No. They are completely unrelated. The loss of photon energy is huge. The gain of vacuum energy is also huge. But they don't cancel each other out. One doesn't pay for the other. One is a massive debit. The other is a massive credit. And neither of them cares about conservation. The photon energy is lost forever. The vacuum energy is created from nothing. It is chaos. It is an economy with infinite inflation and infinite deflation happening at the same time. And the result? The universe is accelerating. It is speeding up. It is running away from itself. The inflationary bank is printing money, vacuum energy, faster than it can spend it, while burning the old currency, photons, in a giant bonfire. This is the engine driving our cosmic fate. So here we are. The first law of thermodynamics is dead on the cosmic scale. Energy is lost. It is gone. It is deleted. But what does that mean for the future? If you were hoping for a happy ending, brace yourself. The universe is cooling. We call this heat death. Because the photons are losing their energy, the universe is getting colder. Every second, the average temperature of the cosmos drops. The stars will eventually burn out. The black holes will evaporate. The galaxies will drift apart until they are so far away from each other that light can never reach them. And the light itself? It will be stretched so thin, so red, so weak, that it will carry almost zero energy. It will be undetectable. A universe full of ghosts. If energy was conserved perfectly, maybe we could recycle it. Maybe we could build a machine to gather up all the lost heat and start over. Maybe we could reverse the clock. But we can't. Because the energy isn't just spread out, it is gone. It was stolen by the expansion itself. The universe is a one-way street. It started hot, it ends cold. It started bright, it ends dark. There is no return policy. There is no refund. And the thief, the culprit, it was space itself. The very fabric of reality is consuming the light that travels through it. It is a slow, silent, unstoppable crime, and there is nothing we can do to stop it. We can only watch. We can only measure the redshift. We can only calculate the loss. We are witnessing the slow, beautiful death of energy. But maybe, just maybe, that isn't the whole story. So, does this mean physics is broken? Does this mean everything you learned in school is a lie? No, it just means the rule book is smaller than you thought. Conservation of energy is a local law. It works in your house. It works in your car. It works in our solar system. It works anywhere where space isn't stretching too fast. We live in a calm little bubble where the books balance and the accounts are fair. But step outside that bubble, step into the vast expanding dark between the galaxies, the rules change. The universe is not a closed box. It is an open, wild, stretching ocean. And here is the beautiful part. If light didn't lose its energy, if cosmic redshift didn't steal those jewels, the night sky wouldn't be dark. Think about it. If every photon from the Big Bang kept all its energy, the sky would still be a blinding 3,000-degree furnace. We would be cooked alive. The theft of energy is the only reason the universe is cool enough for life to exist. The universe is leaking energy, yes, but that leak is what allows the stars to shine against the black canvas. It is what allows us to look up and see the past without being blinded by it. So, the next time you look at the night sky, remember this. You are looking at a crime scene. You are seeing light that has been robbed, stretched, and weakened by the journey. But be grateful for the robbery, because without it, we wouldn't be here to witness the crime. If you want to uncover more lies hiding in your textbooks, hit that subscribe button. We are just getting started. The universe is full of broken laws. Let's go find them.